Hello everyone. Today I am Saptarshid, your host. I will be teaching you gravitation and I will make you understand everything about gravitation. So, in gravitation, we will first study universal law of gravity. In universal law of gravity, according to Newton's, every object in the universe attracts every other object with a force which is proportional to the product of their masses and inversely proportional to the square of the distance between them. The force along the joining center of two objects. Okay. So, what is gravitation? And why are we studying the topic gravitation? So, one day Newton was sitting under a tree, under an apple tree, we all know that. So he saw an apple fall down near him. So he started thinking, why did the apple fall on the ground? Then after thinking a lot, he thought that there must be some attraction to the apple. That's why apple fall on the ground. So after thinking a lot, he given us the universal law of gravity. According to Newton, in universal law of gravity, every object in the universe attracts every other object with a force which is proportional to the product of their masses and inversely proportional to the square of the distance between them. The force along the line joining the centers of two objects. So what is it saying? It's saying, let us take two objects, one object A and one object B. So object A have mass m and object B has mass small m. Okay. So according to the law, every object in the universe attracts every other object with a force which is proportional to the product of their masses. That means F, which is a force, is directly proportional to the product of their masses, mass m, capital M and small m. So F is proportional. This is equation number 1. Then F is inversely proportional to the square of the distance, and let us take the distance as d. Okay. So F is inversely proportional to d square. This is equation number 2. From equation number 1 and 2, we get F is proportional to mass m, capital M and small m, and inversely proportional to our distance between both the masses. Okay. So then by taking a proportional constant g, F is equals to capital G, which is a proportional constant, m, capital M into m divided by d squared. So this is our force. So what is G? So G here is a constant of proportionality. In this case, or in case of gravitation, it is called gravitational constant. Gravitational constant. So what is the SI unit of G? Capital G, gravitational constant. So F is equal to capital G in multiplication of both the masses divided by distance square. So G is equal to force into distance square by capital M into small m. SI unit of force is Newton. If a SI unit of distance is, we can say meter, so meter squared, divided by SI unit of mass kg. Therefore SI unit of G is SI unit of gravitational constant is Newton meter square kg inverse 2. So we have already found this. Right now we will speak what is the importance of gravity. So by stating the Newton's universal law of gravity, Newton made us understand a lot of things, like while there is a rain, this is a cloud, this is a cloud. While raining, this rain is falling on the ground. There is a car, there is a house, this is a house, this is a tree. So why is rain is falling on the ground? By the universal law of gravity, we can state that the earth has a mass m, which is attracting the rainwaters or raindrops, so therefore raindrops are falling down on the ground. Okay, so we can say that anything, for example, there is a building, and on the top of the building you are throwing a football, you are kicking it, and the football is going down. Why it is falling? Because of gravity. Okay, this is earth, this is our earth. Okay, and this is moon. A moon is all constantly rotating around the earth. So why it is rotating? Because there is always a gravitational force which is pulling it towards it. Therefore it is following a circular trajectory. Otherwise it would have gone towards a straight line. Okay, it would have moved in a straight line, but it is moving in a circular trajectory because always earth is attracting it. Always earth is attracting the moon. Therefore it is always moving in a circular manner. Okay, so this is how we can explain various things by gravity. Okay, there is tide. For example, take this as a river. Okay, and this is a normal flow of river. In case of high tide, the amount of water increases to this. Okay, this is the increased amount. And in case of low tide, this is the river water amount. Why it is happening? In case of high tide, moon is more near the earth or sun is more near the earth. So as the distance decreases, the pull increases, the force increases. We can say that F is equals to G m1 into m2 divided by d square. So as the distance decreases, force increases. Therefore water gets pulled. So this is how we can explain tides by gravity. Okay, so this is some of the importance of gravity. Let's say okay, let's take for free fall. What is free fall? For example, you are right here You are right here, and you have a stone in your hand, and you throw it upwards, and the stone takes goes upwards, and let's say at a height at a height at a height h at a height h it gets stopped. Okay, it gets stopped, and from there it will come downward. From there it will come downward. By second law of Newton, we know F is equal to ma. So it will follow acceleration which will happen due to gravity. The earth will attract the stone. So due to that force, there will be some acceleration, and that acceleration we call this m into small g. Okay, this acceleration is called m into small g. This is this acceleration. Okay, we call this at gravitational acceleration. Gravitational acceleration. At some point of time, or at this point, let's say this point or this point or any point, at any point, F is equal to mg equals to, let's say this stone has mass m and earth has mass m. It will be equals to mass of earth into mass of stone divided by distance. So the distance, let us take at height h square. Okay, so let us take h square. So h, it will not be h square, it will be h plus radius of earth square. Okay, so h is pretty much small than radius of earth, so let us take as m into r square. Okay, to find g, we will, this small m is also very small, so we will compare it as m. Mass, by putting mass of earth and the radius of the earth, we will get g as 9.8 meter per second square. Okay, this is what free fall is. Okay, thank you.